Unit 2 is dealing
Recording has started.
favorite part of fractions. That's the fractions. Yes, there's a little sarcasm there. I realize that a lot of people struggle a bit with fractions. And part of that reason is fractions are a little different, but another part is many times we've not been shown how fractions truly interact. We've just been shown the fraction and taught the rules for dealing with it and told follow the rules. So let's take a look first of all what fractions mean. We saw something like 3/4 back on day 1 of the semester. And we were told that 3, called the numerator, but its purpose is it's just a count. It's telling us how many we have. We have 3 of something. And that 4 is called the denominator. That's just a name. Just like having inches or feet or cows or pounds or whatever. That's telling us what it is we have 3 of here. So to understand that fraction, our first step is to talk about what does it mean to have a name of fourths. It means if we have a circle, going back to the old elementary school illustration, which I still think is the easiest way to illustrate it, of a pie or a pizza or whatever, that fourth means that that whole pizza is cut into 4 equal pieces. Now pretend those pieces look equal. 3 then means that we have 3 of those pieces. There's a couple of ways to think about it. Either you can think of every whole object gets cut into 4 equal pieces, or you can think of it as it takes 4 pieces to make each whole object. That's what the fourths means. 3 is just how many pieces we have. Now the first step we need to do, we saw back on day 1 that certain fractions couldn't be combined with addition or subtraction because they have different names. So the first thing we need to be able to do is change the name of a fraction. The easiest way to do that with this illustration is to just take these slices that are there, slices of pizza or whatever you want to call them, and cut them into smaller equal slices. Let's say we're going to cut each of these slices into 3 smaller equal slices. Once again, pretend those are equal. Now, if I count how many slices does it take, how many pieces does it take to make a whole object? 12. Which makes sense. We had 4 pieces before. We cut each of them into 3 equal pieces. 4 times 3 is 12. That makes sense. How many pieces do we actually have? 9. Again, that makes sense. We had 3 before. We cut each of them into 3 equal pieces. Now we have 9. Well, do we have any more or less pizza than we did before? No. 9/12 is exactly the same as 3/4. They're exactly the same amount. How were we able to do that and keep them equal? Well, it comes down to this thing right here. We multiplied by 3 over 3. This 3 is saying we have 3 pieces. This 3 is saying it takes 3 pieces to make a whole object. In other words, that is 1 whole object. It's equal to 1. That is what we call in math is called a unity fraction. And a unity fraction just means the numerator equal to the denominator. It's a very powerful tool because we can use that unity fraction because it's equal to 1. If we multiply or divide by 1, it does not change the value of whatever we're working with. So we can use that unity fraction to change the appearance of a number without changing its value. When we talk in Unit 4 about measurement conversions, we'll use that a lot. We'll have things like 12 inches to 1 foot. Now that doesn't look like it equals 1, but it does. 12 inches and 1 foot are the same value, they're just different ways of writing the same value, that unity fraction can be used to convert measurements from one form to another. Doesn't change the value, it'll just change the appearance. Now here, I just picked the 3 out of the air to use to rename this fraction. In reality, we often have to figure out what that number is. So we might have something like 2/5, and if I want to rename it to be 20ths, I have to figure out what do I multiply 5 by to turn it into a 20? 4. So we have to multiply the 2 by a 4 as well, because it has to be a unity fraction, 4 over 4. What's 2 times 4? 8. 8/20ths is exactly the same value as 2/5. Now we might have 5/6, and I want to change it into 40 seconds. What do I multiply a 6 by to turn it into a 42? 7. So I have to multiply the 5 by 7 as well to get
35.
35 over 42, again, has the exact same value as 5 over 6, because we multiplied by 7 over 7, which is 1. Well, sometimes to rename a fraction, we want to go the other direction. If I wanted to get back to something smaller, I mean, if you're trying to picture 42 pieces to make one whole object, and we have 35 of them, that's hard to visualize in your head. Human psychology, actually tells us the average human can visualize between 7 and 13 objects at one time before they start to get fuzzy around the edges. So visualizing 42 objects is tough to do.
I can do 10.
You can do 10?
That's my first, yeah.
But what we can do is this. Since we multiplied by 7 over 7, we can divide by 7 over 7. 35 divided by 7 is 5, and 42 divided by 7 is 6. And we've already said 5 over 6 is equivalent to 35 over 42. So they're the same number, just different ways, different forms of writing the same value or same amount. Now again, here we had just multiplied by 7 over 7, so we knew we could divide by 7 over 7. The tricky part is looking at a number and trying to decide what it is we can divide by. We talked about that factoring at the end of Unit 1 and divisibility. Here's where that comes into play. First thing I always look for is 10. Well, can either of these be divided by 10? The 60 can, but they have to both be divisible by 10, don't they? They can't divide the 48 by 10, so that doesn't work. How about 5? No. How about 2?
Yes.
Yes, both of them are even, so I can divide them both by 2. What's 48 divided by 2?
24.
4, and what's 30 divided by 2? Or sorry, 60 divided by 2?
30.
Is 30. Now both of them can still be divided by 2. What is 24 divided by 2?
12.
Oh. And 30 divided by 2?
15.
Is 15. Can they both be divided by 2 again?
No.
No. But they can both be divided by 3. Remember, you add the digits, and if that sum is divisible by 3, the whole number is divisible by 3. What is 12 divisible by 3?
4.
4. And 15 divisible by 3?
5.
5. And that's it. 5 and 4 are relatively prime. We can't divide both of them by the same number. No number we can divide both of them by.
Forgive me for coming late.
No problem. Reduces to 4 over 5. They're the exact same value, just different ways of writing it. Now, when you were first learning fractions back in elementary school, you were probably taught you have to find something called the greatest common factor. We talked about that last week. That would be the largest number that divides both the 48 and the 60. In this case, that would be the 12. 48 divided by 12 is 4, and 60 divided by 12 is 5. That would be just, we divided by 2, 2, and 3. If you multiplied those together, that's the greatest common factor. Now, it's easiest if you multiply by the 12, or divide by the 12 at first. You get there in one step. But notice, we're going to get the same spot if we divide by smaller numbers and just work our way down.
Yeah, that's how I was taught. I was in a special needs class and I couldn't break down numbers.
Oh, sure. Yeah, and rather than trying to find that biggest number, it's easier if you just start dividing by twos and threes if it goes into both of them.
How an old teacher told me is better to take small bites than try to devour the knowledge whole.
That's usually true, yes.
She's a big fan of snakes, which was really weird for an old lady. Yeah, sorry about that.
So 44 over 7. Now, if we look at that, the 7 again is telling us it only takes 7 pieces to make a whole object. We have 44 pieces, which means we not only have enough pieces to make a whole object, we can make several whole objects. Figure out how many, if we did 3 by 7, if we just punch this in our calculator, we're going to get something like 6.2857114. Well, that does give us some information. First thing it gives us is that we're going to get 6 whole objects out of it. There's going to be some pieces left over. But it doesn't tell us how many pieces are left over. Generally, it is simpler to do a long division with a remainder. 7 goes into 44 how many times? This tells us it's 6, yep. What is 6 times 7?
42.
42. We subtract, there's 2 left over. This remainder, the 2, is the number of pieces that are left over, the number of the original fraction that we still have. This was sevenths here, it's going to stay sevenths. This tells us how many whole objects we got. So 44 sevenths is 6 and 2 sevenths. Now, we could probably have done that in our head, or many of us would have done that in our head. So what happens if it's bigger numbers? Well, it's still that division and remainder. I have 271 sixteenths. I'll break that down into a mixed number. 271 divided by 16. Does 16 go into 2? No. Does
Nope.
it go into 27?
Yes.
Yep.
1 times 16 is. We'll subtract 17. 7 minus 16 is 1. That's 1 is 1. We bring down the 1. We have 111 left over. Does 16 go into that?
Yes.
Sure.
Yep.
How many times?
I guess 8.
Try 6.
I guess 6.
6 times 16 is 96. Correct?
Correct?
If I
Yep.
from the 1 to 0,
Yep.
this is not 10. 10 minus 6 is 4. If I borrow from the 1, make that a 0. This is now, oops, this is 11 out of 10. 10 minus 6 is, 11 minus 6 is 5. 10 minus 9 is 1, so that's 15. So there's 16 whole objects, 15 pieces left over. And of course, that denominator is still a 16. That is 16 and 15. Any questions there? Sometimes we need to go the other direction. We may have, this is what we refer to as a mixed, called a mixed number because it mixes numbers and fractions together. Proper fraction implies that there's something wrong with it, but there's not. We don't like it because we don't like having the numerator larger than the denominator because it's simpler to put those into whole pieces and have the mixed number. But there are going to be times where we prefer to have that fraction as an improper fraction. So that's what we're going to do next. Let's take a mixed number, like 7 and thirds, and turn it back into an improper fraction. To do that, we have to break this whole number, the 7 whole objects, back into pieces. How do we know how many pieces each of them has?
3.
Our denominator tells us they each have 3 pieces. 7 objects times 3 pieces each makes
21.
Did we have any pieces before?
Yes.
We had 2 of them. So we add that 21 to the 2 we already had, giving us 23 pieces, or 23 thirds. We were taught to do whole number times the numerator plus numerator. That's because you're splitting those whole objects back into pieces. We might have 3 and 5 and 5, 6. So we've got to take the 5 whole objects into pieces, so it's going to be 5 times 6, which is
30.
pretty good. And we add that to the pieces we have, which is the 5, to get
35.
35. 5 plus 30 is 35. And we still have 6. So anyway, we can rename our fractions. Now we can look at doing operations with our fractions. Remember, add or subtract any number plus have the same. Fractions, that means we must have a common denominator. You got it. And of course, we combine counts. Of course, fractions, that means you add the numerators and you keep the same name. Fractions, that means you keep the common denominator. So if we have something like 3/4 plus 1/5. We can't add those the way they're written because they have different names. This has the name of fourths, this has the name of fifths. I need to find the same name, which is a common denominator. There are a lot of ways to find a common denominator. The simplest, multiply. 4 times 5 is 20. Multiply the two denominators. That will always give us a common denominator. It will not always give us what's called a least common denominator. There might be one that is smaller than 20 that would be easier to use. One way to find that is to make lists. We've got 4 and we've got 5. List out the multiples. Remember, multiples were 4 times 1 is 4, 4 times 2 is 8, 4 times 3, 12, 4 times 4, 4 times 5. Now we can stop there because we know that 5 is going to go into 20, right? 5 times 1 is 5, what's 5 times 2? 10, 5 times 3, 15, and 5 times 4, 20. So we didn't find anything smaller, so it goes. They both go into 20. So 20 would be the least common denominator there. The other process we could have done is least common multiple last week when we did our factoring. We could go through and do the factoring and use that to find the least common denominator if we really needed to. If we put algebra in it, we won't do algebraic fractions in here. If the denominator is like 18x squared y to the third and 12x to the fifth alive, and you need to find a common denominator. Factoring would help you find that. I'm trying to make the voices go away there of that one.
No thanks. I'll pass on that.
Understandable. We're not going to do that in this course. Don't worry. To our 3/4 plus 1/5. Bless you.
Thank you. Sorry.
Denominator is going to be 20. Now I add and subtract vertically. It's just the way it makes sense to me. So I'm going to set them up and let's change everything out here. What do we have to multiply 4 by to make it a 20? 5.
You want to come?
So our 15/20ths is the same value as 3/4.
Hey, I'm not.
What? 4. 4. So 1 times 4 is 4. 4. These now have the same names. They're both 20ths. So we can combine the counts. 15 plus 4 is 19. And keep the same name of 20ths. 19/20ths is our result. Now we're not going to stick with simple fractions. We're going to jump up to mixed numbers. And we might have something like 5 and 1/3 plus 2 and 3/8. Or, now notice, I just put the fractions at the end of the number, almost like it's the last digit of the number. In fact, that's all the fraction is. It's just a last digit at the end of the number. I still need the common denominators to add them though, so I'm going to have to rewrite these with common denominators. For 3 and 8, what's my common denominator going to be? 24 will be the smallest one. You got it. What do I have to multiply 3 by to make it a 24? 8. So 1 times 8 is 8. Multiply the 8 to make a 24. I have to multiply by 3. So 3 times 3 is 9. Have the common denominators now. Just like any other number, just like with whole numbers, I start at the end and I work my way backwards. So I'm going to do the fractions first. 8 plus 9 is 17, and that place value is the 24th. So I keep the same name, the same place value. 5 plus 2 is 7. It doesn't stay that simple. We run into things like this. 6 3/4 plus 9 5/6. Now we need a common denominator. With 4 and 6, what's it going to be? 12. 12 will work. 4 is multiplied by what to make 12?
3.
What's 3 times 3?
9.
9. 6 is multiplied by what to make 12? 2. So 5 times 2? 10. Now we go to add here. Again, we start at the end and work our way backwards. 9 12 plus 10 12. We combine counts. 9 plus 10 is 19. And we keep the same name of 12s. That is bigger than 1. It's an improper fraction. How many times can I take 12 out of 19? Once. And how much is left over? 7 12s. Now, just like with any whole number, I'm going to keep part of this. 7 12ths is the fraction digit. I'm going to carry part. I'm going to carry the 1. 1 and 6 makes 7 plus 9 is? That's 16 and 7 12ths. What if you struggled to find the common denominator? Well, I told you could just multiply them if you wanted to. Yeah, you make your list if you need to. But I told you just multiply them if you wanted to. Would that work here? Sure. 4 times 6 is 24. 4 times 6 to make 24, so 3 times 6 would be 18. That's still equivalent to 3/4. 6 times 4, so 5 times 4 is 20. If we add here, 18 and 20 is 38, which is 1 and 14/24. Difference is here we're going to have to reduce 14/24. Both divide by 2 to make 7 12s. Here's the 1, 7 12s. The only difference was we had to do that one extra step at the end where we had to reduce the 14/24 to 7 12s. So if you struggle finding common denominators, go ahead and just multiply the two denominators together. You might have to do a couple extra steps to reduce it at the end, but you should still get to the correct answer. Go to subtraction. Let's do 8 and 7/8 minus 2 and 3/5. We still need a common denominator. What's that going to be for 8 and 5? 40. 8 is multiplied by 5 to make 40, so 7 times 5 makes 35. 5 is multiplied by 8, so 3 times 8 is 24. Just like whole numbers, we still start at the end and work our way backwards. So we're going to do 35/40 minus 24/40. 35 minus 24 is 11, and we keep the same name of 40. 8 minus 2 is 6. Good. Now, just like with addition, it doesn't stay quite that simple. You might have 7 and 1/4 minus 4 and 4/5. We'll need a common denominator. What's it going to be?
20.
20. 1/4 becomes how many 20ths?
5,
5. Good. 4 times 5, so 1 times 5. 4/5 becomes how many 20s?
16.
16. Now we go to subtract. There's an issue. 5 minus 16 can't be done, so we have to borrow. Just like with whole numbers, we borrow from the next digit. The 7 becomes a 6. Now we borrowed one whole object. The problem is, this is pieces, not whole objects. How do we know how many pieces are in our one whole object?
20.
Denominator tells us there's 20 pieces. So we just borrowed 20 pieces, or 20, one whole object is 20 20ths. 5 plus 20 is 25. After borrowing one, that's now 25 20ths. 25 minus 16 is 9 20ths. 6 minus 4. Let's do one more example of borrowing. 9 1/6 minus 5 3/8.
Could you reduce that?
What's that?
Could you reduce the 2 for the 9/20 to 3?
9 can only divide by 3, and 20 cannot divide by 3. Nope, that cannot be reduced.
If 9 divides by 2, 3.
9 divided by 2.
Hold on, what? 9 divided by 2.
9's an odd number, you can't divide by 2. 9 is 3 times 3 is what, if in fact, the way you can tell if you can reduce it is if you have prime factor it. 9 is 3 times 3 and 20 is 2 times 2 times 5. There's no common factor, so it can't be reduced. Now, I know what you're thinking. You're thinking 6. It happens. Don't worry about it. For our 9 1/6 and our 5 3/8, what's our common denominator going to be? We could do 6 times 8 is 48, but there's a smaller one. What is it? 24. 6 times 4, so 1 times 4 is 4. 3, so 3 times 3 is 9. Now we cannot do 4 minus 9, so we have to borrow. That's an 8. What do we add to the 4? 24. The one object that we borrowed has to be split into 24 pieces. 4 plus 24 is 28 24s. Now we can subtract 28 minus 9. 17 24s. 8 minus 5. 3. So 3 and 17 24s. Let's look at multiplication. Look at something like 3/4 times 2/5.
Okay.
When we multiply or divide, do we need the same name?
No.
No, so that means no common denominators. We combine the counts, and then we also combine the names, which means we just multiply the denominators. So we combine the counts. What's 3 times 2?
6.
6. And we also combine the names. 4 times 5 is
20.
20. Both of those can be divided by
2.
2. 6
2.
divided by 2 is
3.
3. 20 divided by 2. 3/10. Now, some of you may have looked at this original problem and thought, why did he cross cancel? Others might be looking at that right now wondering, what's cross canceling? Oh, look at it, the numerator is just going to become 3 times 2. The denominator is going to become 4 times 5. You see that both the 4 and the 2 could be divided by 2, so we could reduce before we multiply. 4 divided by 2 is 2 divided by 2 is 1. Now we see 3 times 1 is 3. 5 is 10. We reduced before we multiplied. In a problem like this, it's about the same amount of work either way. But I could run into something like 24 25ths times 536. 24 times 35,
Good question.
840. 25 times 36 is
Another good question.
900. And I'm sure you see that both of those can be reduced by 60. You see they end in zeros, so we can reduce by 10. 84 over 90. They're both even, so we can reduce by 2. 42 over 40. If you add the digits, this one adds to 6, and the bottom one adds to 9, so they can both be divided by 3. 14, 15. I realize I threw through that kind of fast. We're just a little short on time here, so I'm moving a little quick.
Okay.
That's not horrible, but we work with some big numbers. To me, it's easier if we can do some cross canceling before we multiply. Look at this and realize, hey, 25 and 35 can both be divided by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. 24 and 36 can both be divided by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. Now, if you didn't see 12, you might have divided by 3 or 6. Then you come back and divide by another number until you can't divide by anything else. 2 times 7? 14, and 5 times 3?
15.
50. To me, this is way easier than this. Again, we're not going to spend a lot of time with simple fractions. We're going to jump up to mixed numbers. So we're going to do 5 1/3 times 7 1/4. Now, multiplying mixed numbers is extremely difficult to do. If you went to a university and found 10 math majors, I would be surprised if even one of them could multiply mixed numbers correctly. How on earth are we going to do it? Well, we're going to see. We're going to turn them into improper fractions. 5 times 3 is 7 times 4 is 28 plus 1 is 29, of course. And now we can multiply. Well, this is just multiplying fractions, so we can still, just like any other fraction, we can cross cancel. 16 and 4 both divide by 4. 4 and 1. Now we have 4 times 29, which is 116. Times 1 is 3. And then we have to reduce that. How many times does 3 go into 11? 3. 3 times 3 is 9. That's 2. Bring down to 6. 3 into 26. 8 times 8 is 24. There's 2 left over. That is 38 2/3. Now, just for fun, I'm going to show you how you multiply those. You don't have to ever do this. You don't need to write this down. I just want to show you it's possible. Like if I have 45 times 32. 2 multiplies the 5, but it also multiplies the 4, right? Same thing here. The 1/4 multiplies the 1/3. 1/4 times 1/3 is 1/12. But it also has to multiply the 5. How do I multiply a fraction times a whole number? Over 1. So that's 5 over 4, or 1 and 1/4. 7 multiplies the 1/3. 7 over 1 times 1 over 3 is 7 over 3, which is what is a mixed number? 1/3. And then I just have 7 times 5. 5. Well, I have to combine all these, which means I need a common denominator for all of them, which is going to be 12. So this stays 1/12. 1 and 1/4 becomes how many 12s? 1 and 3/12, right?
Yep.
2 and 1/3 becomes 2 and 4/12. Then we got 35. So we got 1, 3, and 4 add up to 8/12. Well, 8/12 reduces to 4 2/3. Both divide by 2, right? We got 1, 2, and 5 is 8, and 3, 38 2/3. That's what we got up here. This is a lot of work.
You can say that again.
Yeah, I'm going to keep doing it with the mixed numbers. Or with the improper fractions. I'll never make you do it with the mixed numbers. So let's do at least one more example of the mixed numbers before we move on to division. Let's do 3 and 5/6 times 2 and 1/8. So first step is to do what?
Turn them into improper fractions.
Give improper. So 3 and 5/6 becomes how many sixths? Well, 3 times 6 is 18, but we have to add the 5, right? 2 and 1/8 becomes how many eighths? 17. There you go. 2 times 8 is 16 plus 1 is 17. Now here's where we would cross cancel. Unfortunately here, nothing cross cancels. 23 times 17. 191. Times 8 is 48. Then we have to reduce that down. 48 goes into 391. Let's try 7 times. 7 times 8 is 56. So 5. 7 times 4 is 28. 5 is 33. 91 minus 6 is 5. Oh, it could go more than 7 times. Well, how did I know it could go more than 7 times? Perfect. 55 is bigger than 48. So let's try 8 instead of 7. 8 times 8 is 64, so 4 carries 6. 8 times 4 is 32 plus 6 is 38. We subtract, there's 7 left over. So this is 8, 7, 48. Not a real pleasant number. Division is where things get weird. We said that division follows the same rules as multiplication. In multiplication, we combine the counts and then we combine the names. So in division, can I combine counts? 12 divided by 4 is 3. Then also combine the names. 25 divided by 5 is 5. Is that the correct answer? Sure. It is, yes. Does that work every time? No. Sure it does. What? Okay. So why don't we do it that way? Well, because we run into things like this. 3/4 divided by 2/3. If I tried to just divide straight across like that, 3 divided by 2 is like 1.5, right? 4 divided by 3, 1.3. It just doesn't work
Recurring.
out. It never divides out evenly.
Yeah.
So what's it got to do with those? Instead of dividing, we multiply by the reciprocal. We flip it over. Remember, division operates on the number that comes after it. So we're multiplying by 3 over 2 instead of 2 over 3. Times 3 is 9. 4 times 2 is 8. 9 eighths or 1 1/8. Believe it or not, this process comes from what we saw up here of just dividing straight across. Let me show you. Full way of dividing fractions looks like this. We look at the number of the fraction we're dividing by. Remember, division operates on the number that comes after it. Can I reduce 2/3 at all? No. So if that's fully reduced, I take the numerator times the denominator. 2 times 3, which is 6. Now I'm going to use that 6 to rename the first fraction. 3/4 times 6 over 6. 3 times 6 is 18, and 4 times 6 is 24. Remember, 18/24 has exactly the same value as 3/4. I just renamed it. Now, if I divide by 2/3, what is 18 divided by 2? 9, and 24 divided by 3? 8. 9 eighths, or 1 1/8. Answer. Now, believe it or not, it's not that huge of a logical leap to get from here to dividing by the reciprocal. At some point, someone looked at this type of problem and noticed that if we fudge our order of operations a little bit, and there are certain cases where you can get around the order of operations, this is one of them. If we did this division first, what's 6 divided by 2? 3. 6 divided by 3? 2. The result that we got there is always just this fraction flipped over. So they gave it a name, reciprocal. And it's all that's left is to multiply by that first fraction. So when we are taking the reciprocal and multiplying, all we're doing is this process over here. We're just skipping a whole bunch of steps. Well, let's get to our mixed numbers here. Let's do 4 1/5 divided by 1 3/4. It makes sense if we're going to turn this to multiplication that we do the same thing we do with multiplication, which is to make them proper. 4 1/5 is how many fifths? 21 fifths. 1 3/4? 7 fourths. Now this is still division here. First fraction stays the same. Division operates on the number that comes after. So it's going to be times 4/7. Now this is multiplication in every way. We can cross cancel the 7 and 21. Both divide by 7. 21 divided by 7 is 3. 7 divided by 7 is 1. 3 times 4 is 12. 5 times 1 is 5. What do you think? Homework, 32 through 33. 1 through 49, the odd. That's on renaming fractions. Page 41 through 45. 1 through 89, the odd. That's on addition and subtraction. And page 49 through 52. 1 through 87, the odd. That's multiplication. Now, as always, I'm not expecting you to go home and do 113 problems here. Do a couple of the easy ones. If they're going well, skip ahead to the more difficult ones. Make sure you're ready for a quiz on this, possibly tomorrow. If you don't have your tests submitted yet, make sure you get that done so I can get it in the grade book so we stay caught up on grading. If you don't know it, go to Blackboard and see if there's a grade posted. If it's not posted, I don't have it, unless you turned it in the last few hours. Questions?
No.
Well, with that, we are out of